We now have access to 20 robotic arms. We have the configuration of those arms in a variety of different setups, so we can produce component parts up to 6.2 meters in diameter. And we then have the ability, through the use of what are called manipulator tables, to basically produce quite complex geometries.
Hello, I'm Ed Reed, the editor of E-FWD, and I'm here today with Peter Richards from Deep Manufacturing. Peter, tell us about Deep Manufacturing. Where do you come from? What do you do?
Yeah, so thanks, Ed. So great to meet you. In terms of what we do, we make large-scale metal component parts, but using a technology called Wire Arc Additive Manufacturing. We're born out of the Deep Group. So the Deep Group is really split into three core divisions. We have a habitats division, so with the mission and vision to create subsea habitats. And part of the process that we went through with that business was looking at the manufacturing capability to be able to support ultra large scale component parts. So parts that were up to 6.2 meters in diameter was a requirement that we had from a design point of view. That led the business to then look at traditional manufacturing techniques, and that gave two problems. First of all, timescale. So if you wanted to produce ultra large scale component parts for basically subsea hulls, and then secondly, manufacturing complexity. So the ability within our design process to use more exotic materials within the build process. And that then led us to Wire Arc Additive Manufacturing, because it does two things for us really. First thing is it transforms lead time from a manufacturing point of view, because as the name implies, it's additive, so you're building layer by layer. So you've got the ability to basically transform traditional lead times compared to a casting or forging. So you're about a third of the lead time compared to traditional manufacturing processes. And then the second point was then design complexity. Because it's an additive process and you're doing it layer by layer, you've got the ability to also integrate different materials into the build process. So one of the things that we're doing at the moment is using steel with Inconel cladding, and we're doing all of that within that build process. So they were the main core requirements. So the business made an investment into this technology, and we made a substantial investment into the technology. So rather than buying into it in a test the water, we went in full scale and we bought the largest instance of wire arc additive manufacturing machines that exist in a single site in Europe. So we now have access to 20 robotic arms. We have the configuration of those arms in a variety of different setups, so we can produce component parts up to 6.2 meters in diameter. And we then have the ability, through the use of what are called manipulator tables, to basically produce quite complex geometries. So we're involved with Innovate UK at the moment, producing a propeller out of nickel, aluminium, bronze, and also we're involved with other organisations within the energy supply chain, now starting to produce more complex designs and parts from that perspective. And in essence, what we've now got is I've got two routes to market. I've got an internal customer where I'm building subsea hulls. So at the moment, we're in the process of finalising a pressure vessel for human occupation, which will go down to 200 metres in depth and be tested to 200 metres in depth. That's certified by DNV. So we've got an external body to approve our manufacturing approach. And then secondly, with it, within that build process, that will be the first completely wire arc additive manufactured product and pressure vessel onto the market from that perspective. And so that's my internal customer Deep, because that will be a recovery module for our habitats outside of the business. And then obviously I've got capacity now, so I can sell that capacity into the external market, and that's basically what we're doing now.
And so looking at that sort of external use case, who do you think your sort of natural customers would be?
So any organisation that takes or has a requirement for large scale component parts. So actually within the oil and gas supply chain, there's a huge seam of either OEMs or actually the operators themselves that need component parts that are on a very long lead time. The beauty of what we can do is we can basically transform the lead time from a delivery perspective. So we're cutting that by about a third. And then also in terms of the overall build process. So where there are more complex builds within a component part, we can also support one very quickly, and secondly, the manufacturing process that we go through is also certified by DNV. So it gives a degree of confidence back to the industry of what we're producing is suitable for end use as well from that perspective.
I suppose. I mean, have you always been a Wire Arc
No.
devotee? Is this
No,
a lifelong interest? So what brought you to this over sort of other?
Yeah, so basically, my background is prior to being with Deep Manufacturing, I was with an organisation in basically contract manufacturing, which was powder-based 3D printing, CNC machining and injection moulding. And then prior to that, I was with the Classification Society, so I was with DNV, Lloyd's Register, Ingham, Manisher Lloyd. So I've got quite a variety of different footprints that all came together really neatly with Deep Manufacturing, because there was a requirement to look at the manufacturing process, but then also quality, and then how you can ensure what you're building adheres to certain quality standards. So again, I've got the background from a classification point of view that we could then draw into the business here. And we've built a rapidly growing team. If I take on the viewpoint, in January of last year, we were 3 people. We're now at just shy of 40 in the UK. And we've also just taken on a site in Houston, which is 50,000 square feet. So we're expanding rapidly as well from that point of view. So I guess what attracted me to the industry was 2 things. First of all, I'd say leading edge technology. It's not bleeding edge, because actually Wire Arc Additive Manufacturing was patented back in the 1920s, because it's basically a welding wire. So you're taking a welding wire, you're using robotics, you're melting that, and then you're additively building the structure that you want to support from that point of view. So it's a really interesting area from an engineering point of view. The investment that Deep's made into this technology is huge. And to be able to produce component parts up to 6.2 meters in diameter is really unique. So that's what attracted me.
That sounds good. I mean, and so you mentioned, obviously, you sort of got this new base in Houston. I suppose, what's the sort of balance between sort of domestic kind of growth opportunities versus more international?
It's a really good question. I think actually the client base that we're seeing at the moment is truly international. So we're getting a lot of interest from the energy sector, and that's organisations that are global in terms of their remit from that point of view. So there's a real drive and design in terms of where we can support organisations within the energy supply chain, regardless of where they are and where they operate. I think the other point, which is more domestic, is then defence. So we've got the ability to produce very large scale component parts, which sits quite sweetly into the defence sector at the moment. Obviously, with the defence mandates that are going on around the world currently, there's a large amount of investment going into that sector. The advantage that we've got as well in terms of what we can apply to the defence industry is, again, the complexity around designs. If you take, say, a hemisphere to the end of a hull, we're producing those in roughly around about 10 days, about 1.75 metres in diameter, compared to a traditional manufacturing technique, which would take most probably about 2 or 3 months. So again, in terms of where that demand is, the domestic demand is really coming more from those defence segments. We're seeing also that within the States. So we were in Washington in the summer, and meeting with the US Navy as part of engagement with them from an organisation point of view. And there's a real strong demand for this technology in that sector because they can see the need for speed, and that's where it plays.
And I suppose in this kind of conversations with customers, obviously, I suppose it's going to be driving, the sort of the pace of adoption. What sort of questions do they ask? I mean, I think it's always that kind of question around sort of innovation and obviously sort of leading edge technology. But how do they find comfort with your, novel sort of way of manufacturing? I suppose DNV was played a part in that.
Yeah, so I think D&B gives us, in essence, an entry point for open discussions. The challenge the sector has, though, is then multiple different standards. So API, ASME, as well starts to play in, from that point of view. And then also, if you're dealing with, US Navy, it's NAVSEA as well from that point of view. What we're seeing is there's an equivalency around standards. So where we're getting to with your clients is if they want us to abide by, say, API 20S as a qualification requirement, with our DNV standard, we know we're roughly around about 80-90% there. So we can give them that confidence, and then we work through those other areas from a development point of view. So I think there's that point. So standards and certification helps. We then get into material properties, and we go through a very rigorous, and rightly so, testing regime for the parts that we produce. So NDT, DT, so non-destructive testing, destructive testing, X-raying of the component parts as well. And actually, when you look at the build profile that you have with a wire arc additive manufactured part compared to a traditional part, the material properties can be better in a wire arc produced part than traditional. Because if you cast something, you pour the metal into the cast, then the cast set, and then you then hope it's coming out as you'd expect it. The beauty that we've got with the process is we scan each layer. So each layer is scanned by our robotic arms as it builds. And then we go through a full testing profile as well from that perspective. So with any new technology, there is an element of, I guess, questioning around, and certainly in the energy sector, where you've got critical components where you can't have failure. But you could say that about any industry, you can't have failure of a component part. But with the history that the sector's got, is then how you give confidence back from that point of view, which is key. And then I think the other point from a confidence point of view is then also looking at what's looked at hybrid manufacturing. So in essence, what we're saying is, well, we'll take the dumb steel, if I refer to it that way, and we do the exotic welds. So something which is more complex we'll then do, but there's traditional manufacturing as well from that perspective. So you're then getting a blend and best of both worlds, really.
And I suppose just as sort of final question, so looking ahead, obviously it feels like you're doing a lot of things, the expansion into America, not least. Where are you going to be in 12 months' time?
Where are we going to be in 12 months' time? Well, we'll have a fully staffed and operational facility in the States. We will be multi-million-dollar in terms of revenue turnover. We've already got an extremely healthy pipeline of opportunities that are starting to come through now. We'll be of a workforce that I would envisage to be most probably around about 100 to 150. And we will also be looking at other geographic locations as well. As we look at other markets around the world, there's a desire for local content. So if, say, we take the Middle East as being your prime region for us to operate in as well, from that perspective, that has a requirement for local content. That's within our business plan, that we will be looking at those regions, depending upon demand, where we'll then start to set up as well.
And do you have everything that you need to achieve those growth goals?
Do we have everything that we need to achieve those growth goals? Really good question, Ed. I guess the challenge that we've got is people. We are building our own training programs for our technicians. We're just in the process of an apprenticeship program that we're building as well, so that we can develop staff from that perspective. Obviously, when you're expanding globally and you've got an operation here in the UK, and then you then want to go to the States, the change in visa requirements and legislation also then gives you some headaches. That's all, you can overcome all of that, but it just takes time. So I think we've got all the right bits, but as Morecambe and Wise would say, not necessarily in the right order. At the
Not
moment.
yet.
Yeah, not yet. But that's all coming together. So I would say we're in a very strong position to be able to achieve the goals that we've got set for going into next year, and also by the close of next year as well.
Perfect. Peter, thank you very much.
Thank you, Ed.